Hello everybody and welcome back to the channel. Today's video is going to be a little different than I had planned. I originally had planned on starting the two-piece Vice series today, but unfortunately a couple parts have not arrived yet. They should be arriving later this week from the week I'm recording it. And so I'm going to start another little random series called Breaking Endmills, where I see how my machine handles different materials. This week we're going to be seeing what we do in steel. This is a mild steel this time. It's a A36 and it's just some cutoff I had from when I was building the base for my mill to sit on to give it mass. And we're going to see if we break an end mill or if we make chips and see what happens. Also towards the end, I also received in my XYZ location sensor from Openbuilds finally. It's the Touch Probe Plus. I had to do a couple things. You'll see what happens when I show you that part of the video, but you won't see it in the beginning since that was all filmed before I received it, and I just made that add-on at the end with the day I received it. So stick around and hope you enjoy it. I would also like to thank my subscribers. I'm surprised I already got to 20. I'm happy to see that growth. And in the near future, I'm going to make a subscriber giveaway item. I haven't decided what it is yet. I think I'll make it a project video, and then at the end of that project video, I'll give the item away to whoever wins this the subscription. So enjoy the video. Thanks. Alright, instead of showing very small and illegible numbers inside of Fusion, I'm going to use this spreadsheet to show you the feeds and speeds I used. On the top, that's the ideal speeds. That's the speeds that I have set my template to for future steel cutting, at least in mild steel. I haven't tested tool steel yet, so we'll see what happens with that, and I will update the spreadsheet then. In the lower set of two numbers, that's the numbers I actually used in the video itself. I got good finish results. I mean, it doesn't look the best like visually, but when you put your hand on it, there's no rough spots. Everything comes to a nice crisp corner, and it's accurate within, I'd say, I'm trying to remember now, I want to say it was within 0.1 millimeters of accuracy on all the cuts, which for that little machine and its rigidity, that's pretty good for a metal that it's just not meant to cut at all. When I'm cutting aluminum or wood, it's dead on accurate, so I'm guessing it's just steel. And for me, I'm not really cutting much in steel and don't really intend to use it much, but just the fact I can at all is amazing. And these are the numbers I came up with. I think I would get better accuracy with this 3mm step over. I'm going to test that off camera later. But for the video, just know that on the ruffers, I use a Lakeshore Carbide 1/4" rougher. They're both ALTIN Carbide. One's the only difference between on the finishers. I have two different finish ruffers. Or finished Carbide inserts. I have a 1/4" that's short and a 1/4" that's long, and I use the same speeds for both of those, and they seem to not have any difference in the surface finish and cut. And for the speeds, I just use the same speeds for both. They worked great. 18,000 RPMs, that's about the height of the torque to speed curve. Once you start going above 18,000, the torque starts to fall off a little bit, and below 18,000 the torque isn't quite there. So 18,000 seems to be the sweet spot for that spindle, so that's what I run it at. Surprisingly enough, I'm running this thing at 800 millimeters a minute, which compared to my aluminum cutting is blinding fast. And I can't remember if there's any, like, you could see the chips or not, but when I was vacuuming them out of the machine, they were nice and blue and pulling the heat off really well. And then the step over, it will do a 6mm step over on a 1/4" end mill. I wouldn't recommend this for continued use. I'd recommend that 3mm step over. I think it'll just provide a lot less tool pressure and you'll get a lot better finish. And then I just stuck with a 0.5mm depth of cut. I think on one pass on the top it did a full millimeter, and then it did it. You could definitely hear the spindle slow down quite a bit. It bogged down a bit, but it made it through. I just wouldn't recommend a millimeter depth of cut for constant use because you'll burn your spindle up pretty quick. And now let's get on to some of the video. as you can see, it cut the part with relatively no problems at all. Unfortunately, part of the slotting operation, I lost the footage. My GoPro file corrupted for those parts. But you can see where I was doing the finish pass to cut off that lip where it cleaned it all up on the base there. Plus, you saw some sparks when it made contact when it was falling off. Thought that was kind of interesting. Now you're gonna see some high quality shaky cam here as I go over the XYZ touch plate. Thanks for watching. Alright everybody, I'm taking a little break from making projects today. A couple parts I was waiting for didn't arrive today like they're supposed to, so I can't start my two-piece vise project. So I thought I'd take a minute to, one, test the machine cutting steel, which, as you just saw, it cuts it quite well. There's still some chips left here and there. Got to finish vacuuming them out. But the other thing I got today was an Openbuild XYZ touch probe, and I finally got it working. It took a little more work than it should have. It's designed for putting on spoil boards, which are usually made of MDF. However, my entire system is... Hold on. Sorry about that, my compressor turned on. As I was saying, I got the Openbuild XYZ touch plate. It did have an issue though. They're designed mostly to get stuck on wood with some spoil board underneath. But as you can see, my entire machine is steel and therefore very conductive. And how it works is you put a magnet on the tool post here, or on the tool end rather. I usually stick it on the ER collet itself. And then you stick this plate with the wire onto that. So what happens when you do that is it completes the circuit and then it freaks out and doesn't know what it's doing. So what I had to do is I had to put some blue painter tape on the bottom so that there was an insulator between the metal I usually cut and the rest of the machine. So I'm going to show you how that works here. I'm going to try to do it one-handed here. Let's see here. And then here's the magnet you use. I just attach it there. Although probably should hold off on that until this is actually plugged in. Let's see here. We're going to do that. That's plugged in there. Verify that's ground. Yep. Right. And then we're gonna whatever. Hook that into there. Now see if you touch that, light turns on. And gotta get the cable up there so there's a little slack. Alright. Now it's in place. So now what we're gonna do is, let's see if we can get that screen to look decently okay. There you go. So what we're going to do now is we're going to click the probe, and I have the automatic one, so you just click that, and now what we do is we move this so that the end mill is over the hole. And that looks good. Bring her down a little. Alright. So, now that's in that position, so it's over the hole with a little bit of gap on the Z-axis. Click the confirm probe position. I said confirm. Alright, now the probe light turns green. And now is when the magic starts. it's all zeroed now. So then you just take that off, take the plate off. Yeah. Whoa! And that right there is why you don't put a Z-Touch plate on a all-metal surface one-handed. I was able to re-zero and all that, and then we'll pick up from there. Alright, so as you can see, oh, here we go, there we go. It's zeroed out at a 14mm Z offset for now. They just do that for safety margin, so if I were to put that down, I'd put it right on that corner there. And that makes locating for parts a lot easier for setups, and it makes it much more accurate, much more repeatable. Bring you inside for some closing thoughts. Actually, hold on, before I do that, let's go over some of the other stuff though. Alright, so here's the metal part that I machined. It looks a little rough, but you can't feel anything. It's buttery smooth. I'm sure there's probably some minor imperfections in there. Actually, I know there is, because there's about a 1/2 millimeter difference between this corner and this corner. So there's something wrong with either there was a chip in there when I set it up, or my head's a little out of trim. So I'll be looking at that later. So that's the steel part I milled. This is A36 steel. It's mild steel, I suppose, but it's steel nonetheless that I machined in. This little guy made of mostly aluminum with a couple of steel inserts. So I'm pretty happy with that. The other thing I bought is this little, it's for shark bites, but I'm not going to spend shark bite money. I use Lakeshore Carbide, and that entire part was milled with this end mill. This end mill, and this end mill right there. I also finally bought a proper spotting drill. This is a 1/4 inch solid carbide spotting drill. Let's see here. I already had that bowl. This is also another Lakeshore Carbide end mill I bought. It's a 3 fluid. It's supposed to be an aluminum hog, and it's supposed to just absolutely destroy aluminum and take it out of there really fast. And then I had a couple of these I bought off McMaster-Carr. I think these are high-speed steel. That one and this one. Yeah, it's high-speed steel. And then I have a ball nose end mill that is of unknown manufacturer. I have to look at the box. And then my thread mill I've had for a while. I need to get some more of these, because as you can see on my fixture plate, I haven't tapped all the holes. I've only pretty much just tapped the holes I really need to mount this vise for now. And to be honest, that's perfectly fine. I can just take this off since I have locating pins, tap the holes I need, and then put it back on. Let's see what else I got. I got some V-bits that I probably will never use, but I got them. These can also work for spot drills if it came down to it. I got a 1/8 ball nose carbide, and then I've got some 3 fluid carbide end mills. These are 1/8 as well, and then there's a couple more V's in there. And then this is my insert facing mill. I can't remember who I got it from. It was some company out of Michigan. If I can remember the name, I'll put it in the description. But yeah, this is a 3 triangular insert. It works really well. It makes some good surface finishes on aluminum. That's kind of a bit of a chicken to try it on the steel. It should cut it. I mean, it's carbide, so it should work. But yeah. Anyway, this is a nice little holder for it. It holds all the mills I use for the most part. It's designed for like a ER11, I think. You're supposed to, like the routers and shit that like DeWalt and them make. So there's supposed to be like a collet there, and you put your collets in here and your nuts there, and yeah. So the wrench slot I just use for USB sticks. This little compartment has more little V cutters that are too short to stick into this. But it does have a nice little angle gauge, so you know what kind of angle your V-bits are using. So like on this guy, for example, pull him out. You just go down the list and find the one that it fits in. And this one is a 45. I mean, it looks like it could have been a 60, but it's got too much play. 45, it fits perfect, so 45-bit V-bit, degree V-bit. Let's see here. That's about it. Talk to you inside, and thanks for this little sidetrack down. Will it break mills or will it cut steel? I was able to find the company that makes that insert end mill. It's Bush Machine Tool Supply. They're $40. It's a 3/8 shank with a 1-inch diameter face, and it uses 3 TPG 22 inserts. They have a few different things that are kind of interesting. They also have where is it? This guy right here. I have one of these as well that I bought from them. I haven't used it yet. It's still sitting on my desk in my office. It looks like it'd be interesting to try. I haven't really messed with it yet. They also sell the inserts for the mill, face mill, and $1 each. That's a pretty good deal. You get 3 cutting sides per one. They also make some other stuff that isn't quite for me. I don't have a lathe yet, but they sell inserts for the CXA pattern of quick change lathe tooling. They make boring bars, and let's see what else do they make. They make thread tools. So they do a lot of insert stuff, and they seem like decent quality. The stuff I've got so far, it's all built well, and I haven't had any problems with it yet. So if you're looking for a insert face mill for your mini lathe, well, mini mill rather, take a look at them, and they're relatively inexpensive, and it seems to work pretty good. Thanks for watching, and if you liked the video, please subscribe, leave a comment, and a thumbs up. Much appreciated. Next week we should start the 2-piece vise project. I should have all the materials in hand by then. And again, thanks for watching, and appreciate those of you that have subscribed, and see you next week. Have a good day. Bye.